Hello, hello, and welcome to this video on HashSet. So, not much remain in the documentation of HashSet. We had covered till intersection, and now we will continue with union. So, we will quickly finish the documentation. So, let's get started. If you have not watched the previous video, make sure you go ahead and watch the previous videos. Particularly, I believe last two videos are very important. So let's go with union. So as you know, to take union, we need two hash sets. So one is A, another is B. And we have 1 to 3 in A, and B contains 4 to 3, 4. So if you take union, it will become 1 to 3, 4. Now if you iterate over it and collect it, then you will get a hash set, and that should contain 1 to 3, 4. Okay. Now we have contains, we test for membership, so it requires a value. So if you read the description, okay, did I read the description of union? But I didn't. Widgets, the values representing the union, that is all the values in self or other without duplicates. So duplicates won't count twice. Okay. Now we have this Q. Now the type T is of type borrowed Q, and Q must satisfy hash EQ and size. That is, the size should be known at the compile time. Now it returns true if the set contains a value, that is the particular value which we are looking for. The value may be any borrowed form of the set's value type, but hash and EQ on the borrowed form must match those for the value type. So suppose we have a set 1, 2, 3, and we check whether it contains ampersand 1, that will give us true. It returns a boolean. And if we give ampersand 4 here, we take a reference of 4, then 4 will not be found, and we will get false. Then we have get returns an option enum because the element may be found, may not be found, and it contains a reference of the element. The constraints on the traits is same. Returns a reference to the value in the set, if any, that is equal to the given value. The value may be any borrowed form of the set's value type, but hash and EQ on the borrowed form must match those for the value type. So we have 1 to 3, we try to get 2, then we get 2. It is wrapped in the option enum, and if we try to get 4, then we get null. Now this is nightly API, we don't care about nightly API as much. Then we have is disjoint, so it will check between two sets whether the sets are disjoint or not. If you don't remember the set theory, the set disjoint condition is that when two sets do not have any element in common. Okay. So returns true if self has no elements in common with other. This is equivalent to checking for an empty intersection. So we have two hash sets, 1 to 3, and then we get another mutable hash set B, which is empty. Now is A disjoint with B, then it will return true. This also returns a boolean, as you can see. Then we insert 4 in B and we check for disjoint, it will be true again. Then we insert 1 in B and we check for being disjoint, it will become false because 1 is there in A and B both. Then we have is subset, so it will check whether one set is subset of another, that is other contains at least all the values in self. So we have 1 to 3 in superset, and then the set is new, so it's an empty set, typically denoted as 5. So is set a subset of superset, it is true. We insert 2, it is still true. We insert 4, it becomes false because 4 is not in the superset. Then we have is superset, similar to subset. We'll check for being superset. So in this case, we have sub as 1, 2, and our set is empty. So is set a superset, or is sub superset of whatever. I'm missing the terminology. So sub would be superset of set here, which is false because it contains more elements. Then we insert 1, 2, it will be still false, and then we insert 2, then the set will contain 0, 1, 2, and subset will contain only 1, 2, so our subset is superset will be true. Then we have insert. Inserts a value of type t that is the same as the type of hash set and returns a boolean. It's a value to the set, returns whether the value was newly inserted, that is, if the set did not previously contain this value, true is returned. If the set already contained this value, false is returned. And set is not modified, original value is not replaced, and the value passed as argument is dropped. Remember, the value passed as argument is dropped. Okay, so you won't be able to refer to the variable again. So we create a multiple set and we insert 2, it will give us true. If we insert 2 again, it will give us false, and the length will be 1 year. Then we have replaced, we put a value of type t and it returns an option random of type t, adds a value to the set replacing the existing value if any that is equal to the given one, returns the replaced value. So we have a hash set new and we insert into the set a vector of type of i32, which is new. So then we get reference of the empty set, okay, and we unwrap that and capacity would be 0. Now we replace this set with the capacity 10 and we unwrap and get the capacity, it will be 10. Then we have remove, it will take a value of the same type and the traits are what we have studied and it will return boolean. Removes the value from the set, returns whether the value was present in the set. The value may be any borrowed form of the set's value type, but its description is the same. So we have a set, we insert 2, we remove 2, it is true, and we try to remove again, it will become false. Then we have take, similar to other functions, returns an option random, removes and returns the value in the set, if any, that is equal to the given one. The value may be an interval, so the description is quite similar. So suppose our set contains 1 to 3 and we take 2, then return sum 2 otherwise, and if we try to do that again, it will give us none because the set does not have that anymore. Now we have traits implementation, so we can go ahead and look at trait implementation, that what traits the hash set implements. I'm not going to go through all this, at least you have to take some effort from your own side. Okay, so now we have finished HashSet. It was quite fast because we had covered a lot. So at this moment, vector, linked list, hash map and HashSet are done. In the next video, we will go through vectec, and that will be a long one. Let's not go through vectec because vectec is quite similar to vec. We will go for binary heap. Okay, so binary heap is what we will study, and we will not study vectec, btmap and btset. The reason is that we will just read the description of vectec, that is this much, and implementations and all. The basic information, they are quite similar to vectors. Btmap is quite similar to hashmap, other than it is ordered map. Maybe we will go through those. It does not. There is no harm in going through that. It just that it will take some time. We'll go through all of collections. Okay. So in the next video, we will start with binary heap. See how big it is. Okay. Not that big. Okay. We should be able to cover this in 2 videos. All right. So I hope that you are following this playlist along and finding it useful for your Rust programming. So why I go through documentation is that because that is your standard reference material, right? You have to go through documentation to learn, because the details which documentation will give will not be found in any book. Plus, the thing is that if you want, we can go ahead and look at the source straight up, that what it does internally. Okay, for example, if we want to go through vec, we can go and look at the source. So straight up we see that okay, it is a generic type or whatever. So we can look at the source, that what it does. That is the best thing about the documentation of or going through documentation of any type. or any language. If you want to learn any language or database or compilers, go through the documentation. That is an absolute must. For example, suppose I have to write a new C compiler. Okay, if I want to write a new CC or C++ compiler, what I would do is that I will go through either the Clang documentation or the GCC documentation. Once I go through that documentation, I will have a lot more idea about what the compiler does. Okay, where does the undefined cases go, where it does not implementation specific cases go, and what decisions are taken for implementation defined stuff. So all those information you will get by looking at the documentation and the source code. You can read 10 books, okay, does not matter. Rarely any book will cover all that which is given in the documentation. For example, I'll show you. Let's go to the all.html, okay, the one which we had discussed. So if you go through all this, it's just not possible to cover all this in a book. Okay? That is as simple as that. No book can cover this kind of material. So when you won't find information anywhere, not on Stack Overflow, not in AI, I'll give you an example where AI will not be able to cover you. Okay, suppose a new release is done and a new night feature comes into the standard library or the language, then AI wouldn't know. The reason is that AI has not seen any example of this new feature. It has no data to train with. So that is one of the reasons why I cover everything into documentation by reading it. So with this, I will end this video here, and in the next video, that is after 4 days, and that is if I don't miss anything in between, we will start with binary heat. Okay. And in case you are wondering about the new look of the desktop in the video, it is Elementary OS. Okay, I have done a brand new installation of Elementary OS. So it is beautiful. I love it. Okay. So if you want to see the fonts and all, I can show you. So this is Roboto Mono font. You can customize your terminal to use Roboto Mono, and I also use Roboto Mono in the editor as well. So it is not fully installed yet. So if you want, you can go ahead and give a try to Elementary OS. It is a bit old because it is based on Ubuntu 24.04. And I'm waiting for the next release when it will contain the 26.04. I'll upgrade the system. So it works nicely. If I need anything latest and greatest, I will use Docker and I'll get that. Most of my work is limited to Rust and JavaScript, so that is you can install any version you want on old operating system as well. So it does not give me a problem. So I will end this video here, and remember, in the next video we will look at binary heat. So stay tuned for the next video, and thanks a lot for watching. I'll see you in the next video. Till then, stay curious, keep learning, and most importantly, enjoy.